Hello. In this video, we will be looking at a cost volume trade-off problem where we have four different options of how we can get the material, the products, the units, the subcomponents, whatever they are, get the things we need. We can pay a different amount of money up front and different upfront fixed costs come with different variable costs per unit. And we're just trying to figure out what option we should use. And we want to come up with a little decision list so that we know, oh, if I need 1,000 units, okay, I should use whatever it is I should use. So here's how we're going to go about this. We're going to make a little graph here, and across the horizontal axis, we'll be increasing the number of units that we are buying. And then on the vertical axis, we have cost, money. And we could spend the time to make a very precisely accurate graph, but I think we can get to the answers we need without needing to spend as much time making a detailed graph. So let's forge ahead. I'm going to start with C because it has no fixed cost. It's the lowest fixed cost. And if I only need one unit, the thing with the lowest fixed cost is going to be the thing I know for sure C is what I'm going to use if I have a very small need for whatever this is. So I'm going to start where the fixed cost here is $0. And I'm going to, looking at the variables here, the variable costs here, 20 is one of the highest ones. So I'm just going to make a line that's arbitrarily steep. D will be a little bit steeper, but C is going to be pretty steep. So I'm going to draw C looking like that. And now looking at these fixed costs, the highest one I have is $20,000. So I'm just going to decide that's $20,000. So 1, 2, 3, 4, 5. Okay, so I guess this is 4, 8, 12, $16,000. And with a fixed cost of 20,000 is one I need to draw, and then 10,000 is going to be there, and then 18,000 is going to be right there. Now, now we just need to draw them, and I'm not going to worry about the exact slope. I'm just going to pay attention to how steep they are, depending on which is the highest cost and the lowest cost, etc. So C has a pretty steep slope, but D, starting here at 18, it's going to have an even steeper slope, right? Because its unit cost is $21. So I'm going to start it at 18, and I want to make it a little bit steeper than C. So I'm going to do that. I'm going to do D. Doesn't look like D is going to ever be the cheapest, I'm sorry to say, because it's just going off to infinity at the highest price, and so it's never going to catch C. So it doesn't look like it's ever going to be cheapest. So we've graphed D, and we've graphed C. Let's graph A, because it has the lowest variable cost, so it's going to have the flattest slope. So I'm going to draw it like that. And that'll be A. And then B starts here at 10,000. And it has a slope. C had a slope of 20. A has a slope of 12. And 15 is somewhere in between. So I'm going to draw it like that. And that's B. Now, the way I've drawn this, well, what we're trying to figure out is what's the cheapest for any given number of units. And because I was not being careful about my slopes, I should not expect my horizontal axis to really be to scale, but it should still hopefully show me which is the lowest for a while and then which is the lowest for a while. So the lowest cost, as we said earlier, is C if we only need like one unit. And so for a while we go along and C is the cheapest. And then it looks like we hit a spot where B becomes cheaper. So from 0 to whatever this is, C is going to be the cheapest. And then we're going to go along. And then we're going to hit that point right there, this point right here. And so between 0 and whatever this is, C is cheapest. But in here, B is going to be cheapest. And from here on over, A is going to be cheapest. So we need to find these breakpoints. Okay, so, and, you know, like we saw, D, it looks like D is never going to be the cheapest. It does cross, I mean, it's cheaper than A, but it's not the cheapest, obviously. So let's find these crossover points, these breakpoints. So the first one I'm going to look for is where B and C cross. The cost of B is $10,000 plus 15 times X, where X is the number we are looking at. The cost for C is 0 plus 20 times X. So I subtract 15X off both sides, and we get 10,000 equals 5X, divide both sides by 5, and we get X equals 2,000. So I'm claiming that this break-even point there is 2,000. Then we need to see where A and B cross. Oops, sorry. So the cost of A is 20,000 plus 12X. And I want to know where that is equal to the cost of B. And the cost of B is 10,000 plus 15X. I subtract 12X off both sides, and I get 3X. And then I subtract 10X off both sides, 10,000 off both sides, and I get 10,000. Dividing both sides by 3, and I get X equals 3,033. So again, my drawing is not to scale all that well, but I don't really care. It helped me figure out the answer, and that's what I care about. So my final answer then would be, and I'm just going to do this over here. So if X is between 0 and 2,000, what option should I use? Well, 0 to 2,000, I should use option C. If the amount I need is between 2,000 and 333, I should use option B. And then if I need greater than or if I need greater than or equal to 3,333, I should use option A. And that's my answer. Now you might be thinking, you know, I'm a little uneasy with this whole thing because you were just making up these slopes. And that's a legitimate complaint, a reasonable concern. And if you want to go and check the math, since I claim the last breakpoint was 3,333, you could go and figure out what would be the cost of, say, 4,000 units, 5,000 units, and draw the picture more accurately and see what it looks like. And it will look like this, but a little different scale, obviously. But if you don't want to go to that extent, but you're thinking, well, you know, how do I know that how do I know that B is even in the picture? Maybe just we go from C straight to A. So again, I am claiming that this is the end of the story and that's all you really need to do. But if you don't trust your drawing, let's just see where the breakpoint between C and A would be. A has a cost 20,000 plus, oops, sorry. A has a cost of 20,000 plus 12X. And C has a cost of no upfront cost, it just has a cost of $20 a piece. So if I subtract 12X off of both sides, I have 20,000 equals 8X. So X is Okay, I need a calculator here, right? 2,250. Oh, is that right? Let's see. No, 2,500. See, you should always be skeptical when I'm doing math in my head. I'm not as good at it as I think I am. So 2,500. So let's go back to our picture here. The breakpoint between C and A, that's at 2,500. So what do I think I proved by doing that? I proved that the breakpoint here is at 2,500 and it's between 2,000 and 3,300. So the drawing is maybe not perfectly to scale, but it's topologically correct, if I could say it that way. Like the structure of it is correct. So to recap, we looked at the fixed and variable costs for each option, and we drew a picture by starting with the we started with the option that had the lowest fixed cost, and it had one of the highest variable costs. So I drew with a pretty steep slope. And then I looked at the one with the steepest slope, and I did take my fixed costs between 0 and 20,000, and I did make this vertical axis to scale, at least to start out with. And then I drew D because it has the highest variable cost. I drew it as being even steeper than C. And then I drew A and B as the flattest and the second flattest. So A has the lowest variable cost, so I drew it with the flattest slope, and B has a slope in between the other two, so I drew it with the slope in between the other two. And that's how I decided that the cheapest option between 0 and some point here is C, and then between these two, the cheapest is B, and beyond that, it's A. And so then we had to go solve for it algebraically, and the cost of using B is 10,000 plus 5x, setting that equal to the cost of C, which is 0 up front plus 20x. We got x equals 2,000. And then the A-B breakpoint was 20,000 plus 12x. That's the cost of A. Cost of B is 10,000 plus 15x. So we get x equals 3,033. And then our final answer was this little chart here. So if x is between, so if you say, I don't know, I need 5,000 units, okay, that's more than 3,300. So we should choose A. Or if I need, I don't know, 1,000, well, that's less than 2,000, so I should use C. So that's how we look at these problems. I hope this has been helpful.